So in this problem it says, let's consider the tangential or radial components of a discus as it is being thrown. A discus thrower turns with angular acceleration equals 50 radians per second square, moving the discus in a circle of radius with a value of 0.80 meters. Now we're asking us to find the radial and tangential components of acceleration of the discus and the magnitude of its acceleration at the instant when the angular velocity is 10 radians per second. So we just draw a picture to represent it, and we have the radius up here, and it's going to be 0.80 meters per second. We have the discus going to the left in this point, and we have the angular acceleration 50 radians per second squared. But now the radial and the tangential components are going to be like this. The radial is going to go toward the center. In contrary, the tangential acceleration is going to be tangent to a circle, so this circle right here. One thing we should also know is that the acceleration, the radial acceleration and the tangential acceleration are both components of the linear acceleration, and the linear acceleration is represented of the line drew right here. Now to find that tangential, the tangential acceleration, we just multiply the radius by the angular acceleration. In this case, it's going to be 0.80 meters times the 50 radians per second squared. So for the tangential acceleration, we get 40 meters per second squared. For the radial acceleration, we got the omega squared times the radius, which is 10 squared times 0.80 meters, and that is 80 meters per second squared. Now to find the magnitude, we have to square root the sum of the squares of both the radial and the tangential acceleration. In this case, it's going to be square root of 80 squared plus 40 squared, and that should give us 89 meters per second squared.